All right. Well, I'm not really sure what's happening right now, but we are here on day 2. I did get the page to load. There does seem to be some issues, so we'll try to stay on the same page and get through this together. I do, however, still need to get my puzzle input, so we'll just get going and hope that I guess that it works out and that we can submit. So day 2 is Red Nose reports. Apparently, the historians or the engineers still talk about the time Rudolph was saved through molecular synthesis from a single electron. Analyzing unusual data. Puzzle input is the unusual data. Many reports, one report per line. Each report is a list of numbers called levels. So these are levels. 6 reports, each containing 5 levels. Trying to figure out which are safe. The levels are either all increasing or all decreasing. Any 2 adjacent levels differ by at least 1 and at most 3. So we're going to have to go through these one by one. It would be nice if we could keep some state around to know if they should be going up or down. We can definitely do this through using Windows to get like this one and the next one, or even peaking. So let's see. 76421 safe because they're all decreasing by 1 or 2. 12789 unsafe because 27 is an increase of 5 and that's more than 3. Okay, so let's grab this. This is potentially a great case for table-based testing. We could put each of these here individually. We could write our parser, parse this out. Not a terribly complicated parse today, but let's get our input in here. The overall answer should be 2 reports. So each of these, whether they are safe or unsafe. So I think we'll just jump in with nom today. So we'll write a function to parse. It'll return an iResult. And we can get back a vec of reports. We don't really need this to be a report specifically. This is just going to be a vec of numbers itself. So we could do something like this and say just a report is a vec of i32s. iResult does come directly from nom, so we need to pull that in. So this is basically going to be, or rather, if you're not familiar with nom is a parser combinator library. It allows you to combine a number of parsers in a compositional way to end up with something that parses. So we can do a separated list starting with new lines with another separated list separated by spaces. And we'll call these i32s. And we need to pass the input in there. Bring all of these into scope here. So we've got nom character complete new line space 1, separated list 1, and iResult. iResult is our return type. This is a super generic return type, so it's really nice to have this as inferred typing from this parse function so that the iResult that is effectively part of all of these parsers and all of their return types kind of gets inferred through that whole chain. And the other thing I'll do is just use miet in here. Again, we're using the miet result type to get that string. The error is a different kind of report. Not super important. The only really important thing is that if this parse fails, we'll get an iResult, which is effectively a regular result. We're going to map over that error and say parse failed because of this. And then we return that in case this whole thing fails. So we can debug this out and check our reports here. Let's look at the numbers 76421, 76421, 12789, 12789, and we should have the last one as well, 13679, 13679. Cool. So now we've got all of the reports. We've used kind of a type alias here. So we can return a vec of i32s as a report, but it gives us some nice documentation for what we intend to have here. Now we could also do that to the i32 and call it a level, but you know, there's a trade-off between more type information and how usable it is. So what we've got here for nom's perspective is a function that takes an input that's a string slice and returns an iResult, which is effectively a regular result. But there's a bunch of generics in here. The error generic is actually defaulted for us, so we don't have to specify it. This is the type of the input, so it's also a string slice. You can also work with byte slices or any other kind of input. And this is our return type, so we're expecting to return a vec of reports out of this. A separated list, separated by new lines, is effectively the same thing as saying dot lines in Rust, which then uses the separated list parser for spaces. So we've got digit, space, digit, space, digit, space, digit, space, digit. This is our report, new line, here's a new report. And then we just call it on the input. And because Rust is an expression-based language, we're returning the return value here, which gets pulled out through this whole function. So if we do end up running into some, trouble, or we wanted to write more granular tests, we could pull this out into its own parser and parse them individually. Well, we basically have to write our testing here now. So the levels are either all increasing or all decreasing, and any 2 adjacent levels differ by at least 1 and at most 3. So we have to do a difference probably an absolute difference. And then it would be nice if we could keep around whether this is an increasing or decreasing process. So we could do something like an enum. I know slope is a terrible name for it, but I can't remember, or I can't think of anything better. So we have the option of doing like something like this with a increasing, decreasing to keep that around, or we could just do, a negative or a positive. If it's negative, it's obviously decreasing. If it's positive, it's obviously not. So we do need to windows on this or chunks or something like that. In iter tools, there is a tuple windows. This would allow us to specify the number of items that we want out. So if you have a range from 1 to 5, so that's 1, 2, 3, 4, and you do a tuple of 2, that will infer to be 1, 2, 2, 3, 3, 4. So we get all of the windows that we need to process. There are a number of other windows functions, but the downside is that some of them are nightly. So the array windows is kind of the same thing, but it uses an array and const generics instead of a tuple. And you can go try to use this if you want to use nightly, but we're going to stick with stable for now, at least for today. So we'll write a function called safety that is report, and that returns, I think we'll return a safety here. This could be a Boolean. I do kind of like doing more type information. So we do need to do report.windows, but we won't have windows available to us just yet. And to do that, because we're using iter tools, we have to pull in the extension trait for iter tools if we're going to use this. And this will be tuple windows. And we could go with a regular for loop here. So on this iterator, the iter tools extension trait gives us this extra function called tuple windows. We get A and B from that. And I called this slope earlier, but I think direction is probably a better name for it. So we've got let mute direction equals option direction. We started off with none. We have each of them going A, B. And for each pair, we now need to test basically A minus B. And we can do diff.signum to get the integer, the direction. Now we could do something really interesting here, and we could go from, an integer to a direction. And if we look at the docs, we basically have an I32. We either get 0, 1, or -1. If we're in 0, we're going to return unsafe because it should never be 0. It has to be between 1 and 3. If for some reason it's anything other than these numbers, that should never happen, so we'll panic. And that'll get rid of this little match issue here. Of course, I didn't show that because I already knew what the issue was from, the years of experience. But this is what you'll see: non-exhaustive patterns, I32 min and I32 max not covered, or, a bunch of numbers that are not covered. These are actually ranges. And that's because this returns an I32, not an enum of some kind. So if we're -1, we'll match direction. And one of the cool things here about Rust is that you can use Rust Analyzer to fill these match arms for us, but it will only do the outer sort of enum or the outer wrapper. So we want to look at both of these. Another cool trick that we're using here is to do, which will shortcut the type inference and allow you to not write code until you're ready to write it. So in this case, for -1, if we match on the sign and we haven't set a direction yet, that means we're in the first phase here, or the first pair. So we'll set direction to some direction increasing. And if we're decreasing and we were decreasing, we don't need to update direction. We just need to leave it there. But we do need to check that the value of this diff is between 1 and 3. So if it doesn't, then this is unsafe. I see that there's an issue on diff.abs. I think this is probably going to be a reference. So here we have mismatched types. .contains expected a shared reference to something found in I32. That's an easy fix for us. We just add a shared reference there. And if it's increasing, we can't switch direction. So -1 is a negative direction, a decreasing direction. If our last direction was increasing, then this is unsafe. If our last direction was decreasing, then we need to do our range check. Otherwise, if it's not in the range, it's unsafe. And we could have a continue here because I think we can just bail out of this loop, or not bail out of it, but we can go to the next segment. That would happen anyway in this case. But we basically need to copy this logic again for 1. These will invert, however. So we'll take the logic that we had here, pop it up, take the logic we had here, pop it down. I think I just noticed that I actually did get the wrong direction here. So -1 should be decreasing, 1 should be increasing. And then if we are also increasing and we just had a 1, then we need to do our range check. If it's not in that range, we actually don't need to do the absolute value here either because we know this is positive. And that should work. If it gets through all of this and doesn't return, then it's actually going to be safe. So I'll rename this kind of check safety probably. And we'll do reports.iter.filter check safety.count. So we've got a report here. We want to do check safety for safe. However, there's an interesting issue here. Actually, the first issue is that we can't do comparisons here, right? So check safety on report equals safety safe. We actually can't do that until we derive partial eq here. This is how we implement equality. In this case, we have a total equality, so we also use eq, but that's kind of more of a marker. So we still have an issue here, mismatch types, check safety on report, expected a vec of I32s, found a double reference to a vec of I32s. So we have a reference, and we actually don't need to modify anything down here, so we can take a reference, and that's actually enough for us to handle this. We don't mutate this report at all, so we don't need to take ownership of that report, or that vec actually. So we get our result here, we toString that, and we're getting left 2, right 1, which means that this is probably incorrect. I did something wrong in this check safety. So in this case, we should have safe, 4 unsafes, and a safe. And thinking about this in my head, I believe that the issue is going to be a range. So if we look at these ranges, right, 1.3, we actually want to include 3. So we'll hit equals here, because otherwise this is an exclusive range. And now our test is passing on the left. So if you have 1.3, it means 1 and 2, but not 3. This is the difference between an inclusive range and an exclusive range. So day 2, part 1, we get 593 if we've written our logic correctly. If we put this in here, that's not the right answer. So we have a situation where we're passing the test data, but we're not passing the actual data. I wonder if this is related to the actual input. This is one of those unfortunate situations in which you pass all of the test input, but you don't pass the actual input. This is actually fairly common in Advent of Code, unfortunately. Let's check to make sure that we're getting all the right safeties here. So some interesting things we can do. We can map here instead, and we can check safety report. So this will map it into the actual safety value. And then we'll have a safety value here, which we can then debug with inspect, which has no side effects. This will then become a safety value. We actually didn't implement debug for safety, so we can go do that just by doing derive debug, and then our debug here will work. And then safety is a shared reference here, so we can just do a shared reference. And if we run this, we get a whole bunch of safes and unsafes. And if we run this on our test, we get safe, unsafe, 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 safe. So there's something wrong here, something we missed, some bug in this logic here. And unfortunately, we won't find it in the test input. So we've got to do some analysis and figure out what it could possibly be. Now, I think that there could potentially be items that are maybe too short in the puzzle input. It doesn't look like that's the case. So let's do this. Let's say debug the report, but instead we could probably just instrument this. An instrument comes from tracing, and let's get rid of this debug because we won't need it. But notice that even as we remove that inspect, we can just leave our filter and map here. So we run our code again, we get our faulty output, and that gives us a whole ton of output. That's mostly because we're not skipping the input in our first tracing wrapper here. So this input is getting added as context to everything, which you can kind of see here. Like our check safety log has the report and whatnot, but it's also including all of that input. So just get rid of that. And now we start to see info logs from our check safety function with the report. And if we go back down to our check safety function, since we're already logging the input, which is our report, we can also log the output, which is the return value. So again, what I'm doing here is Rust log equals info, which is part of tracing subscriber, which we haven't really talked about, but is really nice for debugging. So we're setting up tracing subscriber here. And this is just some like basic defaults, more or less, to output the logs that we want like this. And because we have our functions instrumented, they will automatically instrument the arguments, but we can specify to also instrument the return. So if I drag this over so that we can see the logs and whatnot, we actually now have a log for every report that comes in and the safety value. So because we're returning that, I'm just going to get rid of this info log here. And now we only have the logs for that function with the context. There are multiple kinds of output for tracing here, by the way. We're just working with, the defaults. I didn't really change anything. We get the function that we're inside of, the argument for that function, the value of that argument, the crate that we're in, which is day 2, part 1, as well as the return value. So this is unsafe. We haven't specified a return value for why this is unsafe. So this is increase 1, increase 1, increase 19, 20, 21, 3, increase 2, increase 1, increase 3, and then a decrease. So this is definitely unsafe. And I'm just going to go through this, I guess, off recording, and I'll tell you when I've like found the one that is the issue. One thing that I do want to do is make sure that 0 is actually unsafe. A report only counts as safe if the both are true. All increasing or decreasing, and any two adjacent levels differ by at least 1 in most 3. While I was doing that, I actually had a thought. This might be a great opportunity to show off some error handling. This, after all, is basically just a result. So we can do some really basic error handling here. And then we'll use a result for where the OK value is unit, because we don't actually care about it, and the error value is a capital S string. So this will change all of our return values here. Anytime we want to return unsafe, we'll have to wrap this in an error. And in this case, what I'm going to do is just a really basic format for this capital S string. We could actually build this out into a full error type, but this is advent of code, so I'm going to keep it reasonably quick. And basically what I'm going to do here is error format 2 values with display formatters switched to increasing for this increasing switch. If the diff is negative and we were increasing in this cycle, then that's an error. And in this case, we have an error where if it's not in this range, if the diff isn't in that range, that is, then we have format AB diff value is whatever. And I'm going to copy these for the error messages. And in this case for 0, the diff was 0. Otherwise we panic. Otherwise this is all okay. And we'll return a unit here. Now this will change our logic up here. So we'll iterate over, we'll check the safety. In itertools, there's a filter OK. So it returns an iterator adapter that filters every OK value with the provided closure. It's not quite what we're looking for. So we have a result here, and we can just do is OK. So let's run our test again and make sure that our test passed. We've got one passing test here. And if we run this again, we can look at this output. And now our return value for every single one of these has why it failed. Okay, I've spent a bunch of time looking through all those results, and I can't say that I'm really any closer to figuring out where the issue is. So I'm going to check my logic again, read my code, and make sure that everything is being processed, which means adding another log here, I think. And this should have 95, 93, 93, 90, 90, 87, 87, 86, 86, 85, 85, 83, 83, 80. Looks like everything's being processed appropriately. Okay, so we are not checking something. I think it'll be in none, because we're doing this contains check in decreasing, but we aren't doing it for the first. Really unfortunate that there's like one line in here buried. So in this case, we'll do basically the same code for none, except we have to set the direction. Same here as well. And that gave us a different number. So there were 3 out of, I don't know, 600 plus examples. Yeah. This is one of the things I don't like about advent of code. The fact that there's a hidden difference in the real input compared to the test input. And it's not particularly easy to detect. But we did get to learn about some debugging tools today. It is unfortunate, but we were able to get it in the end. So if we go over what we did again, we've got our parser. Parser, probably the easiest part of today. Separated list by a new line, separated list by spaces, which gives us all of these as vecs. This isn't technically a new type, so we type aliased this report to vec I32 so that we would always have report in our type signatures and remember what that was. But this is just a vec of I32s. So then we take the reports, we iterate over them. In this case, we're mapping and filtering because we haven't changed the code back. But this could just be a filter report check safety is okay. And if we run that, we get the same result, 585. So this check safety function is doing all of the work. And then we're counting the number of safes. We're using result here so that we could get a little bit more information from the errors. This is not strictly an error type in Rust, but you can absolutely do this if you don't really care about matching on the errors after you get them back, which we don't. We really only cared about it for this return instrumentation. So we accept a shared reference to a report and we keep some state around, which is the direction. Option because this might be set to none when we start. And then after the first batch, we actually have it set and we can check against it. We iterate over a pair of all of them with tuple windows, get the diff, check the diff against the sign. So we either get -1, 0, or 1. For each of those, they're either going to be checked against something that was already increasing, already decreasing, or hasn't been set yet. If there's a switch between decreasing and increasing, then we have an error. If there's a continuation, Then we check it against the range. Again, this is a little bit more verbose than it could be because we are doing all of this extra error reporting while I was trying to debug that. And then, of course, the important part is that we also do the bounds check for the first pair as well. I think we could refactor this to be a little bit more concise. We could do the signum and only handle the switches here. And then at the bottom, only write this code once, but I'm okay with this for now. I'll refactor it later. It is, after all, fairly long today because I had to do so much debugging because the actual input didn't match the test input we were given. So for part 2, I'm going to read it and decide how much time it's going to take since part 1 already took some time. And this is probably what I would suggest that you do as well if this is your first time going through it. If part 1 happens to take you some time, especially because of a problem like we just ran into where the input and the test input don't actually match, there are different problems with the actual input, don't feel like you have to keep going after that because that is actually pretty exhausting. So the problem dampener lets the reactor safety system tolerate a bad signal, a single bad level, in what would otherwise be a safe report. It's like the bad level never happened. So same rules, except if removing a single level from an unsafe report would make it safe. The report, oh, we have to actually remove the level? That's really annoying, actually. They don't specify which level would have to be removed, so it could theoretically be any level. So if removing 7 fixed 2 to 8, then that would be fine. The easiest way I can think of doing this is basically for any unsafe, test all the combinations of remove one of them. I think it generally being a early day, it's pretty reasonable to think that we can brute force this. The question is there an easy way to drop one when it's unsafe? I think there is. So if the check safety for the report is not okay, we can either do it like this with a exclamation point or is ERR is also an option. Then we can potentially loop over with an index for index in 0 dot dot length. We'll just clone the report, make this mutable, new report dot remove index, and then if check safety report is okay, return true, else continue, which means that if we get past this loop and they have all been errors, then this is false. Let's see, new report is a shared reference, so the data it refers to cannot be borrowed as mutable. You might want to intermute here. Why would we intermute? We have a vec here, and we need to do new report here. Oh, it's a double shared reference. Got you. So we can dereference one of those shared references because this is a double shared reference to a vec here, and then .clone, which will give us the vec of I32s. We can remove an index from this report based on the index that we're looping over and check, basically brute force all of them. And our test passes, I think. So we'll run part 2. We get 626, which is a bigger number, and that's the right answer. So I am going to call that a win for the day and leave it at brute force, considering how long debugging the first part took. So the interesting part for the second part of Advent of Code is that we switched our filter here so that if this check safety was an error, then we try to check all possibilities for all removals of all numbers. We could probably do this in a more efficient way. I just don't care, honestly, after doing all of the debugging for the first part, which was pretty frustrating. So we brute force it. It's early enough for us to still brute force stuff. This won't run quickly, right? If I cargo bench this, we are running in 390 microseconds, 400 microseconds. I'm assuming these are both slow compared to everybody else. I'm okay with that. So if our check safety is an error, then we loop over all possible indices, we clone our vec, we remove one of the items from the new cloned vec, and then we check like this. If any of these passes, then we're good. We're looking for any possibility, and otherwise we're not. So we actually changed 0 about our check safety code. All we changed was how many items we're actually checking. So again, generally not the fastest today. If you're interested in more of the variations for part 1 and 2 of day 1, I did do more. You can see them up here. They'll be in the Git repo. This will also be in the Git repo. And I hope you learned something about debugging today, especially with tracing, because we spent quite a bit of time with it. I hope your input didn't cause you as many problems as mine did today. But if it did, I hope you got through it and that you're still prepared to go into tomorrow. That's it for today for me. I'll catch you tomorrow for day 3.